Okay, so thank you very much. So hello everyone. So thank you very much for joining the today class. So today the third class of the data science course, and the topic is unsupervised machine learning with the practical implementation. So unfortunately, so Dr. Moazzam, so he had urgent meeting with the chairman HEC. So today, Mr. Kaleem Abbas, so he will teach you the today lecture, the data science, unsupervised machine learning with practical implementation. Okay, so Mr. Kaleem Abbas, over to you, please. You can start and you can share your screen and you can start, please. So, Mr. Kaleem, can you hear me?
Okay, can you see my screen?
Yes, we've seen it.
Okay. Uh, Today we are going to discuss unsupervised learning related things in artificial intelligence. As we saw in the last session that we broadly have three categories of artificial intelligence: supervised learning, unsupervised learning, and reinforcement learning. And we saw supervised learning in the last session, but agenda of today is to talk about unsupervised learning. So, unsupervised learning is a type of algorithm where we don't have any label in our data set. So we only have features, and based on features, we will give this data to the algorithm of any unsupervised learning algorithm, and that algorithm will assign labels based on features and such as characteristics or similarities between the records. So, for example, here we have data where we have apples and watermelon, and when we will give this data to the any unsupervised learning algorithm or model, that model will categorize uh, uh, labels based on the features. As we can see, it categorized into two classes, apples and watermelon. So let's suppose here we have different birds and animals, and when we will give data to unsupervised learning model, that model will classify or assign label according to the features or similarities. So in unsupervised learning, we don't have any labeled data, but as we saw in the last session, uh, where we talk about supervised learning, where we had labels. So in this unsupervised learning methodology, model will give us label based on features. So we will only have features in our data set. So broadly, we can categorize unsupervised learning algorithms, or we can say problems, into two types: clustering and associations. In clustering, a model will create different clusters based on similarities or characteristics of features that we will provide to the model from our data set. While on the other hand, if we talk about association, in association, model will create a relationship between variables such as how one variable will increase and how it will impact on another variable. So in unsupervised learning, we have broadly two types of algorithms: clustering algorithms and association algorithms. Let's suppose if a customer will purchase butter, so how likely it is that it will also uh, purchase bread along with the butter. So this kind of problems are related to association, where we can solve problems like market basket analysis. While on the other hand, clustering means building clusters, or we can say groups based on similarities. So as we know that we have three types of broadly three categories of artificial intelligence: supervised learning, unsupervised learning, and reinforcement learning. So in supervised learning, we will have data with labels, and we will pass that data to the supervised learn model, and that model will predict an appropriate label for us. But on the other hand, in unsupervised learning, we have data without labels, and we will pass that data to the model, and model will predict classes or labels based on similar features. While if we talk about reinforcement learning, where uh, we will not give any data to the model, and model will itself learn from the environment. So if a model will go towards the correct direction, then we will give reward to the model, and if model will go in a wrong direction, or in simple word will predict a wrong thing, then we will give a penalty to the model, and model will try to improve by with the help of penalty, whatever we will give them. So in today's session, our main focus will be unsupervised learning, and uh, we are going to basically discuss clustering algorithms such as k-mean clustering algorithm or hierarchical clustering algorithm. So k-mean clustering algorithm is a clustering algorithm that will classify data based on similar features. So if we talk about internal working of clusters, k-mean clustering algorithm, how it will form clusters. So first of all, we will pass our uh, random k values to decide how many clusters we want to form. And k means simply means that how many clusters we want to form. And we will pass k values to the algorithm, and our k means algorithm will randomly initialize centroids inside from the data set, whatever the data set we will pass to the k means algorithm, and will assign each data point to the closest centroid based on Euclidean distance algorithm. So when we'll pass the value of k to the k-mean clustering algorithm, k-mean clustering algorithm will automatically generate random centroid values. And how many centroid value it will generate? It will be based on the value of k. If we will pass value of k as 3, then it will generate 3 centroid values. Select 3 centroid values from the data set, whatever we will pass to the k-means algorithm, and then it will calculate distance from centroids of each data point from the data set. And then it will again compute error that if we meet the requirement or convergence criteria, and if the error is maximum, then it will recompute the centroid value using the cluster membership value. And if a convergence criteria is not met, then it will repeat all the process again and again. What will be convergence criteria? It will depend on problem to problem. For example, we can define convergence criteria as how many iterations we want to perform, or what would be minimum error. So it depends on us what we want to assign convergence criteria. Convergence criteria is not met, use centroid values and calculate Euclidean distance of data points from the centroid value. And if convergence criteria is not meeting, then it will repeat all the process again and again. So another type of unsupervised learning algorithm is hierarchical clustering. And in hierarchical clustering, we have different number of clusters at each level. For example, in first level we have one cluster, then next level we have two or four cluster, and we are building a hierarchy of clusters. So dendrogram is a way to represent hierarchical clustering. As you can see, this is a dendrogram where we are demonstrating the hierarchical clusters. So broadly, we have two types of hierarchical clustering: agglomerative clustering and divisive clustering. Agglomerative clustering is a bottom-up approach uh, where we will consider each data point as a single cluster, and then moving forward and making combining one clusters to make two data sets of a cluster, and then uh, moving upward and form a single cluster. So we are building hierarchy of cluster by following bottom up approach. So on the other hand, in divisive clustering approach, it is opposite of agglomerative clustering, where we are following top-down approach. In top-down approach, we will consider all data sets as a whole, a single cluster, and then we'll divide data set based on similarity by following any distance measurement formula to form next level hierarchy of clusters, and then dividing and forming more and more cluster and building a hierarchy of clusters. So in summary, agglomerative clustering method is following bottom-up approach, and divisive clustering is following top-down approach. So in uh, agglomerative clustering, we will also implement this in the implementation. It is famous as compared to divisive method. So let's talk about the internal working of agglomerative clustering, how it is working. At the beginning, each data point forms a cluster, also called such as node, or we can say every data point will be considered as a single cluster, and then we will merge each nodes that have the least distance, and then go on merging and build a hierarchy. Eventually all nodes belong to one cluster. So let's talk about the measuring distance. So if we talk about agglomerative clustering, how it is building clustering. So it is building cluster hierarchy of clusters based on distance, how different data points are, and how the data points are similar to each other. So we can follow different approaches to measure the distance in the to build a hierarchy of clustering, such as single linkage or complete linkage or centroids. So if we talk about single linkage measuring distance, where we will consider minimum distance. So every point who has minimum distance will form a single cluster. So if we talk about complete linkage, where we will consider maximum distance. So every point that will have maximum let's suppose Euclidean distance, and that will form a single cluster. And uh, s- uh, another way to measure the distance is centroids, where we will assign each any centroid value and will compute distance from centroid value, and every point that has less distance from the centroid value will be considered in a single cluster. So what about distance? So what methods these the clustering algorithms are using to calculate distance of data points? So if we specifically talk about numerical data, uh, and let's suppose k-mean clustering or agglomerative clustering, most of the time we will follow Euclidean distance to measure the distance between different data points. So let's suppose if we talk about k-means clustering algorithm, then uh, we will calculate distance from centroids, and then we'll take square and under root to calculate the distance of all the data points values. Let's suppose x-axis, y-axis, and if we have any other axis like z-axis, then we will subtract these values with the centroid value and will form a distance, and will calculate a distance, and every point that has less distance from the centroid will go to that cluster. And another way to calculate distance is Manhattan distance, where we don't have any square root or under root. So let's talk about the evaluation. So how we can evaluate the performance of unstructured, supervised learning algorithm. So unsupervised learning, to evaluate the performance of unsupervised learning, we should keep in mind that intra-cluster cohesion should be maximum. It's mean that within the inside the clusters, similarity of points, data points should be maximum, and inter-cluster similarity should be minimum. Like clusters should be different from each other. So a well-known measuring algorithm to check the performance of unsupervised learning algorithm is sum of squared error. So we will compute some square error in the implementation to check the performance of unsupervised learning model. So, but we also considered expert judgments to check how accurate our clusters are. So these are a few recommended videos that you can watch if you want to learn more. So let's move forward to the implementation part. So today we are going to implement k-mean clustering and agglomerative hierarchical clustering in unsupervised learning algorithms. So as we discussed in the last session that we must consider NumPy, Pandas, sklearn, and matplotlib libraries. So these are essential libraries if you want to work with machine learning implementation in Python. So uh, we are importing k-means clustering algorithm from sklearn library and pandas library, and we are also importing min max scalar to normalize values, and matplotlib to visualize graphs. So let's run it. So the next step is to import data set. So if we are using Google Colab, and if we want to import data set, then we can consider Google Drive to import data set. So the first step is to connect Google Drive with our Google Colab. So just click on this button and click on mount button. But as you can see, I already mounted the drive, so I don't need to mount it again. So in first line, just give the path of dataset where your dataset is located inside your Google Drive. So the path would be content slash drive slash my drive slash datasets. So datasets is the name of directory that I already created in the Google Drive, and inside this datasets directory I have a CSV file of dataset income, and we should use pandas library to read the dataset. And if you want to read dataset of CSV file, then you can consider read CSV algorithm of pandas, and just pass the path of your dataset, and it will read dataset from the location that we provided as path, and this pandas library will store the dataset in the form of data frame. So it will store in the df is a variable that is representing to the data frame. So data frame, as we discussed in the last session, that data frame is just you can consider it as a Excel sheet or a table, like you can consider it combination of rows and columns. And df dot head method will give you will show you top 5 records what we have in our data set. So we are considering name, age, and income of different peoples. So as you can see that we don't have any target variable in this data set. We only have name and age and income. So we will pass this data set to the k-means clustering algorithm that will create clusters based on their similarities, such as people's age or income. So let's plot this data set on scatter plot. So we are using matplotlib library to plot scatter plot, and we are calling scatter plot method. And inside this method, we will pass the names of columns. So it will the pandas library will extract that columns data and will move to the scatter plot library. And we are assigning X label age and Y label as income. So let's run it. So as you can see that this is a scatter plot, and we are visualizing a data set of income and age in our 2D plane. So the next step is to create a k-means clustering model with the help of sklearn library. So we already imported k-means clustering algorithm with the help of sklearn library, and just calling the k-means clustering and passing n cluster is equal to 3. Uh, n cluster is equal to 3 simply mean the value of k, whatever we have the value of how many clusters we want to create. So if look at the data set, we can see that there could be 3 clusters we can form. So that's why we are passing 3 as a value. And the next step is to call fit predict method on k-means clustering object and passing data set, unlabeled data set. that will only contain features. So our features are age and income of people. Let's run it. And here we are printing y predicted. Predicted is a Python list that contains all the label, or you can say clusters. So here model predicted 201 as clusters value. 0 means cluster 0, 1 means cluster 1, and 2 means cluster 2. So we have total 3 clusters. And model classified value of age and income based on their similarity. So we already have in data set, we already have name, age, and income of people. And here we are adding another column in our data set that will act as target variable, you can say, or name of clusters, whatever the model already predicted. And then in the next line, we are printing first 5 rows. So let's run it. So here you can see that we have name and age and income, and this cluster column is representing, you can say it is prediction of K means clustering algorithm, whatever the cluster K means predicted based on age and income and their similarities. So if we want to check what were the centroids in our k-mean clustering algorithm that the model we have trained, so we can use it by calling method on k-mean clusters centroid, and it will show us centroids that the model learned during the model training process. So here we first value is representing to x, and the second value is presenting to the value of y, and we have total 3 centroids as we gave value of k is equal to 3. So let's visualize cluster whatever the model predicted with the help of scatter plot, and we are going to plot that clusters on scatter plot. And in the first line, we are just extracting um, clusters where cluster is equal to 0, cluster is equal to 1, and cluster is equal to 2 from our data set that we created, and assigning and giving that. And in the next step, using scatter to plot the scatter plot, and then giving age and income as data set to visualize, and color green, red, and black. And then in this line, we are giving centroids and representing centroid with steric, and assigning color as purple, and then assigning X label as age, Y label as income, and then calling a method legend. Legend is a simple method that will uh, allot area to draw aforementioned characteristics that we assign to the scatter plot. So let's visualize it. So here you can see that these are clusters that model k-mean clustering model formed. But as you can see, these clusters are not accurate, and you can check these colors that they are not accurate. So what is the reason that why these colors are these clusters are not accurate and good? So the reason is, as here you can see, the value of age is smaller as compared to income values where we have large values. So building relationship between small values and large values is difficult for the model. So what we should do to solve the issue? So we should have to perform some kind of pre-processing steps. And the thing that we have to do is to perform the process of normalization. So in the process of normalization, we will scale value in a specific range. So in our next step is to normalize the value of income. So we are using min-max scalar to normalize the value of income. So min-max scalar is a famous algorithm that is being used to normalize the value of income, where it will consider minimum value from the income and maximum value from the income, and uh, def, uh, will define a specific range, and every value will be in a defined range. So we already imported min max scalar from skeleton library while we were importing these libraries, and just calling scalar.fit method and passing income, because we want to normalize the values of income. That's why we are passing income from df. Df contains our data set. So we are passing income, and the next step we are calling scalar dot transform, that will transform, or you can say convert our, replace our values with the new values. And we are also transforming age and scalar. So we are normalizing both income and age. So let's run this cell and let's check it. And here you can see that now we normalized value of age and income between 0 and 1. So every value will be between 0 and 1. So now let's use k-mean clustering algorithm again to pass these updated normalized values to the algorithm, and let's see now how it will form clusters. These are predictions, you can say label of clusters. So now these are updated cluster values. And here we are checking new centroid values. And then same using scatter plot to plot again these values. So now, as you can see that now we have a better cluster as compared to our previous clusters. As you can see, we have red or green. Let me show you previous clusters, and then you can compare that clusters with these clusters. So let's see, these are our previous clusters. So as you can see, these are not good clusters. And let's move to new clusters. So here we have much better clusters uh, as compared to our previous clusters. So how we achieved this, we used the way of normalization as pre-process step to before training the k-mean clustering algorithm. So next question is, what should be the value of k in our k-mean clustering algorithm? Like what should we give the value of k to the k-mean clustering algorithm, and how should we decide that how many clusters should be from our data set? So a well-known approach that we can consider to guess the value of k is elbow plot technique. So in elbow plot technique, as you can see, we will start using value of k from 1, and gradually will increase the value of k from 1 to 2, 3, 4, and so on. And then we will compute some scared error of every k values, and will draw a plot, and whatever the k value will give us a less error as compared to other errors, and we will consider that k value as our optimum value for the k-mean clustering algorithm. So we will start with the value of k from 1, 2, 3, 4, 5, and so on, and will pass every 1, 2, 3 value to the k-mean clustering algorithm, and we will train k-mean clustering algorithm on each k value, and will compute sum of square error, and uh, every k whatever the k value is giving us minimum sum of squared error, and we will consider that k value as our optimum case to train k-mean clustering algorithm. So let's consider what is sum of squared error. So sum of squared error is simple, in which we will pass the value of k, any k value, to the k-mean clustering algorithm to train, and then to compute sum of squared error, we will calculate distance of every data point from their centroids, and then just add up all these distance to form a sum of squared error, and sum of squared error will be the distance of all the distances that we already summed up. So let's do this process to guess the value of k. So here you can see that we are declaring a Python list and name it as SSE sum of squared error, and starting the value of k from 1 to 10 using for loop, and iteratively giving each k value to the k-mean clustering algorithm, and passing age and income as unlabeled dataset, and k-mean clustering and fitting k-mean clustering is simple mean training k-mean clustering, and then computing the sum of squared error of trained k-mean cluster algorithm, and we are using k-mean dot inertia method that will give us sum of squared error, and just adding all these errors, appending all these error in SSE list. And let's now draw a plot to see that what k value will give us less error. So let's run it. So this is the elbow technique. So as you can see that uh, we are considering this elbow symbol. So what this elbow symbol is denoting us, it is representing to the k value as 3 as optimum value. So whatever the k value we have here, we can consider that k value as optimum, and that k value will give us much good clusters as compared to other k means other value of k's. So let's consider another example to draw k-mean clustering algorithm. And from the last session, as we saw that we used Aris flower dataset as supervised learning algorithm, and with the help of regression algorithm, we trained model to classify the name of flower based on features like sepal, width, height, width and length, and based on 4 features. Regression algorithm was predicting the name of flower. So here we are again using Aris flower dataset as uh, uh, with the help of k-mean clustering algorithm, and k-mean clustering algorithm will classify the name of flowers. So in this case, we will eliminate the target attribute column that was name of flower. So we will only use features. So let's import required libraries, and we are using sklearn library to import arrays dataset that is given by sklearn library. So we are not importing this dataset from Google Drive. So this time we are using sklearn library to import arrays dataset. Let's run the cell. Let's load arrays dataset. Storing dataset in the form of data frame. So here you can see we have only 4 features: sepal length and width, and petal length and width. And we don't have in this data set, we will not use any target variable. So as you can see, these were flower names. So we will not use this flower target variable. So to make problem more simple, we are removing 3 columns from this data set: flower and sepal width and sepal length. So we are using drop method to remove these columns from our data set. And now in our data set, we only have 2 features: petal length and petal width. And based on these 2 features, k-mean clustering algorithm will create clusters, or you can say classify it in the form of flowers. So as we know that we have 3 types of flowers in our data set. So that's why how many clusters we should form? We should form 3 clusters. That's why we are giving 3 values to the k-mean clustering algorithm, and calling dot fit predict method and passing data set to this k-mean clustering algorithm to form clusters. So let's run the cell. So these are the predicted labels, or you can say name of clusters that k-mean clustering algorithm predicted based on features. So in this case, what were the features? So the features were petal length and petal width. So model predicted based on these features. So let's add this feature in our data set. So here petal length, petal width, and we added a new column cluster and corresponding their cluster labels. And cluster labels are 0, 1, and 3, and we have 3 clusters. So 0, 1, and 2, these are 3 clusters. And in this column, we are extracting we are splitting each record based on clusters, like cluster where the cluster equal to 0, extracting our records will go to df1, and all the row values where cluster is equal to 1, we are storing in df2, and then 2 for, and cluster is equal to 2, we are storing in df3. So let's run it. And then we are using scatter plot to plot these values. So here you can see that we have 3 clusters, and these are their x-axis and y-axis, their corresponding value of petal length and petal width. And using elbow, and we are also using, we already knew that we have 3 types of data, 3 types of data in our data set, like we have 3 flowers. But that's why we gave 3 value of k is equal to 3 to the k-mean clustering algorithm, but we can also verify the value of k with the help of elbow plot technique. So we are just repeating the process, starting the value of k from 1 to 10 and plotting sum of squared error. So to consider the elbow technique, as you can see that the optimum value, it is also denoting 3 based on the given data set. So it was the k-mean clustering algorithm, and we considered 2 examples to show you the real world implementation of k-mean clustering algorithm. And we are now moving to implement agglomerative hierarchical clustering algorithm. So as you know that we have broadly 2 types of hierarchical clustering algorithm: agglomerative, and the second is divisive. So agglomerative as a well known, that's why we are considering this. That is, and the next step is to just import corresponding required libraries: matplotlib, pandas, numpy. We are importing these libraries and reading dataset from Google Colab. And in this case, we are considering mall shopping data. So let's run it. Check the shape, how many rows and columns we have in our data set. Like we have 200 rows and 5 columns in our data set. 5 columns simply means 5 features in our data set. So let's have a look. First 5 records. These are 5 records. The data set is representing to shopping mall data set, where we have customer gender, male or female, age or annual income or spending score. So as the spending score from 1 to 100. So we are removing few features from our data set, and we are using ilog method of numpy. And column means we want to extract all the rows, and then after comma we are giving how many columns we want, from 3 to 5, included 3, and 5 is not included, so it will not consider 5th column. So let's run it. So this is the data set that we extracted. So this data set is representing to so this data set is representing to age and annual income. So to make problem more simple, we will consider only 2 features from this data set to form clusters. So our aim is to form hierarchical clustering. In hierarchical clustering, at each level, we will have different number of clusters. So we will build a hierarchy of different clusters. So here we are using SciPy library, and in SciPy library, we are importing hierarchy to build hierarchical cluster algorithm, and to visualize hierarchical clustering clusters. As we saw in the slides, that dendrogram is a way to visualize hierarchical clusters in a much better way. So we are building a dendrogram based on data set. So in data, we have 2 features. So let's run the cell. So it is the, as you can see, this is the dendrogram where it is building hierarchy of different clusters. and we are using a method to build this hierarchy of clusters. We are using the method of word. The method of word is simply mean, as we saw in the slides, that to measure the distance, we can follow single linkage or complete linkage or centroid method to measure the distance. And the centroid method is based on word method. So in simple word method, in word method, we are following centroid method to calculate the distance and to form clusters. So it is building hierarchy. And agglomerative clustering, dendrogram is also used to consider how many clusters we should form, as we saw in K-mean clustering, that we used the method of elbow technique. But here, if we talk about hierarchical clustering, then we can also consider dendrogram to uh, to uh, to predict the value of uh, hierarchical clusters. So what should be the hierarchy? So what is the number of hierarchy? So in the dendrogram, we 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 will have to check what is the longest vertical line where no horizontal line is cutting to that vertical line. So just removing that vertical line, and whatever the remaining hierarchy of clusters we have, and that number of clusters we can consider to build hierarchy. I cannot properly visualize this here because I don't have any pencil to highlight this, but you can consider this is the longest vertical line in dendrogram, and this is the area where no horizontal line is cutting to this vertical line. So this is the area, and we will draw a line from here and will eliminate all the upper clusters and will consider all the lower clusters. So how many remaining clusters we have? This is cluster 1 and cluster 2, 3 and 4 and 5. So we have 5 clusters, and we should pass 5 as value to the agglomerative clustering algorithm. So that's why here we are value of k, you can say in terms of k means clustering, the value of k, or you can say number of clusters, we are giving 5, and using Euclidean distance to measure the distance, and linkage, as we have single linkage or complete linkage, but in this case you can also consider single or complete linkage, but in this case we are using word method that is based on centroid to calculate with the help of Euclidean distance to form clusters. And then the next step is to dot predict and passing data, and it will form the hierarchy of clusters. So let's run it. And to visualize the label, just print the labels variable. So these are 5 clusters labels. It is not in good. It is not good in visualization. So we can plot it on scatter plot. So we are passing data set to scatter plot. So these are 5 clusters, and you can see that these are good clusters, and it is much better. So it is all about the implementation work for today, and we saw unsupervised learning algorithm, k-means clustering, and agglomerative clustering of hierarchical clustering. So if you have any question, you can ask, please.
Okay, so thank you very much, all of you, and thank you very much for the Mr. Kalim Abbas. Okay, so any student who have any questions, so you can ask, please.
Assalamu alaikum,
Sir, am I audible?
Yes.
Sir, my question is, if we have outliers in agglomerative and hierarchical clustering, so how can we
Yes.
detect?
Yes, that's why we have different types of linkage methods to consider. For example, uh, we have different methods like single linkage or complete linkage. So if we can consider single linkage, that is following minimum distance to form clusters. So that is sensitive to outliers. So that will not consider outliers inside the clusters. So if we talk about complete linkage, that complete linkage method to form clusters will also consider outliers inside the cluster because it is following maximum distance to calculate the um, to form the cluster. So you can consider different linkage methods to detect outliers. So the next question.
Okay, so one candidate is asking about how can we apply for the job through plus W. So basically, we are getting different opportunities regarding the AI, ML ops, and data science. So now currently we have opportunity in the artificial intelligence and the uh, ML ops domain. So the candidate who have experience in the Kaggle competition or any other competition have experience, and some who are basically get the bronze medal or the silver or gold in the Kaggle competition or Kaggle. So then definitely you can share your CV to our email. So I will share my email on the chat. So then you will share your CV if you are interested and you have experience in the AI domain and in the ML ops. So you have opportunity currently. Okay, I have shared my email address. So you can share your CV or resume. So if you are suitable, so then we will share your CV to the respective Japanese organization. Any student other, if you have any question regarding the unsupervised algorithm or any other, so you can ask, or any other questions if you want to ask, so you can ask, please. Okay, if any student you don't have any questions, so we conclude this lecture today here. So before concluding, so we will take a picture. So every time at the end of class, we will take a picture together. So please open your webcam, so then we will take a picture together. So basically, this picture we use in our website. So for the news and for the blog in our website, please don't worry. So you can open your webcam. It's fine. Okay, so now I will take a picture. So please smile. Okay, so thank you very much. So the next lecture will be on 17th. So hope to see you in the next lecture. Next lecture will be on the recommendation and prediction system with the practical implementation. So please join the next lecture and also share with your students and your colleagues. So definitely they will also join the lecture on 17th. And last lecture will be on the 20th of March. So then after Ramadan will start. So this data science course will end on the 20th of March. So hopefully you are enjoying this data science workshop. Okay, so thank you very much, all of you to join the today lecture, and Mr. Akim Abbas, thank you much for you as well to deliver the today lecture. So it's a very nice,
Thank you.
interesting
Thank you.
lecture for me as well and for the students. So thank you very much. Okay, Allah Hafiz.